Hi students, how are you? I think it's fine. Today we will discuss about the total basic concept of the cell. Okay, so it is actually the fifth lecture of module 2 of chemistry syllabus. What is the module 2 of chemistry syllabus? Module 2 is that it is the use of free energy in chemical equilibrium. Myself, Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering. You know, chemistry syllabus is included in the BTech first year course. The code for the chemistry is either CH101 or CH201. So, what is the today's topic? So first of all, we'll discuss today the basic concept of the cell. Okay, so cell means there are two kinds of cell we'll discuss today. So first one is the electrochemical cell and second one is the electrolytic cell, and then we'll discuss few topics which are very much related to the cell. So this is included, actually these parts are mainly from the electrochemistry part. Okay, electrochemistry part means there is a relationship also with the Gibbs free energy and the EMF of the cell or like that. That's why it is included in the portion of the module 2. Okay, so first of all I will discuss that what is the cell or how we can define the cell. In simply, cell can be defined in this way, that it is the device which convert the chemical energy to electrical energy or electrical energy to chemical energy. That means there are two wings of the definition. So first of all, we can tell that the cell is the any device which can store the energy for a long time, or it is a device which can convert the energy from one form to another form. Okay, which can convert the energy from one form to another form. Okay, so you know that without cell there are so many devices which we are using, starting from our cell phone, without which at that point we can't live. We think in this way actually. So starting from the cell phone, starting from the your wristwatch, your clock, whatever, there is a source of the energy. Actually this is actually the lifeline of the device. Okay, either there is any source of electricity, that's okay, but if there is no such kind of direct source of the electricity, then this kind of cell is the main way or the lifeline of the device. So there are two main roles of the cell. So first one is it can store the energy for a long time, or it can convert the energy from one form to another. Now mainly cell, we can classify the cell in the two ways. So first type of cell is the electrochemical cell. So cell can be classified in the two ways. Okay, so first type, this is the electrochemical cell, and another is the electrolytic cell. So first one is the electrochemical, and second one is the electrolytic cell. Okay, so electrochemical and electrolytic. So what is the electrochemical cell or what is the electrolytic cell? So if we consider the electrochemical cell, then in case of electrochemical, you have to keep in mind, that here chemical energy will be converted to, this will be converted to electrical energy. Okay, this is very important. I will show you that how in the electrochemical cell chemical energy is converted to the electrical energy, but you have to, for the definition purpose, you have to keep in mind that in case of electrochemical cell, the chemical energy will be converted to the electrical energy. But in case of electrolytic cell, there will be different it is the opposite direction with respect to electrochemical cell. So in case of electrolytic cell, if we can write down you can write down, in case of electrolytic cell, you can write down that electrolytic cell here electrical energy, here electrical energy that is converted to the chemical energy. Okay, so electrical energy is converted to the chemical energy, just opposite direction with respect to the electrochemical cell. Okay, so I'll show you with one example that what is the electrochemical cell and what is the electrolytic cell. So first we will discuss about the electrochemical cell. So if we take the example of the electrochemical cell, so this is the electrochemical cell. So in the electrochemical cell, just look the example of the electrochemical cell. Okay, so in the electrochemical cell we will take the two chambers. Okay, so first of all, this is one chamber, for example this is one chamber, and this is another chamber. Okay, this is another chamber. Okay, okay, so there are two chambers are there. Now in these two chambers, okay, so there, okay, I am making two chambers are same. Okay, otherwise it will make the confusion that the size will be different or not. So more or less it is now more or less same. Okay, so now in these two chambers, suppose we are taking the two there are two electrolytes are there. So what is the electrolyte? Electrolyte means which carry the current. Okay, that means, you know, in case of metal, electrons carry current, but in case of here electrolyte solution, here ions carry the current. So which are the strong electrolyte? That means where the number of ions are high, it can carry the current. Okay, and in the left hand side electrode, suppose we are taking, this is the zinc sulfate, it is the zinc sulfate ZnSO4, and in the right hand side it is the copper sulfate. Okay, so it is the copper sulfate. So there are two electrolytes we are taking. In the left hand side, this is the zinc sulfate ZnSO4 we are taking, and in the right hand side there are copper sulfate CuSO4 we are taking. Okay, then we'll connect the two chamber. Will connect the two chamber by the or will dip the electrode in the two chambers. Okay, so in the left hand side electrode will dip, in the left hand side electrode will dip the zinc rod. Okay, so in the left hand side we are adding here zinc rod. Okay, suppose it is the zinc rod, it is the zinc rod. Okay, is the zinc rod, where here it is dipped in the solution. In the right hand side electrode, look here, it is the copper rod. Okay, it is the copper rod. So in the zinc sulfate solution, there is zinc rod, it is present in the zinc sulfate solution. Okay, in the zinc sulfate solution there is zinc rod is present. It is the zinc, pure zinc metal, it is dipped into the solution, and in the copper sulfate, here pure copper metal is dipped into the solution. Okay, then what happened? We'll connect the two two rods by a wire. Okay, this is the wire, and by which we can connect the two chambers. Okay, and you can add a galvanometer here to identify either there is any electricity flowing or not, because electrical energy means, you know, this is the electrical energy. So you can add here any galvanometer by which you can understand either any kind of electricity is flowing or not. So now look here what happened. So zinc is dipped into the zinc sulfate solution, and copper is dipped into the copper sulfate solution, and they two are connected through a wire. So what happened now? Now what happened? Zinc come to the solution as Zn2 plus, That means what will be the reaction? In the left hand side, if we write down that in the left hand side the reaction will be zinc, it is converted to zinc 2 plus 2E. It is the reaction. Okay, so left hand side there will be zinc comes to the solution as Zn2 plus by leaving or by losing 2 electrons. So what happened? These 2 electrons are present here in the metal rod. The electrons are present here. So if each and every zinc atom comes to the solution by losing 2 electrons, so these electrons will be in the metal. So what happened? These electrons come to the wire and it comes to the right hand side electrode, isn't it? So in the right hand side electrode, look here in the right hand side electrode, what happened? In the right hand side, there in the solution there is copper 2 plus, isn't it? So in the solution there is copper 2 plus. So if there is copper 2 plus, then copper 2 plus will goes to the electrode. Okay, so what is the reaction in the right hand side electrode? Look here, copper 2 plus, after taking 2 electrons, it is converted to neutral copper. So left hand side zinc 2 plus, zinc converts to the Zn 2 plus by losing 2 electron, and right hand side copper 2 plus by taking 2 electrons. Copper 2 plus means copper 2 plus is coming from the copper sulfate, because in the solution there copper sulfate present, so Cu2 plus plus is equal to 2 minus. So copper 2 plus by after taking 2 electrons from the electrode, it is directly converted to the neutral copper. Okay, so that means ultimately what we're getting. So ultimately there is a full reaction. If you write down the full reaction, then zinc plus copper 2 plus, this gives zinc 2 plus copper. This is the full reaction. Okay, but ultimately due to this full reaction, we are getting some flowing of electrons through the wire. That means if you connect a bulb here, if you connect a bulb here, then you will get a light here. Okay, so you'll get a light here. So ultimately a light means a flowing of electrons, and we are getting the electrical energy. So that's why it is called actually electrochemical cell, because at first there is some chemical energy. That chemical energy means chemical reaction. Due to this chemical reaction, there is some electrical energy which is produced. So chemical energy is converted to the electrical energy. That's why it is called the electrochemical cell. Okay, so now there are some facts which you have to know. First of all, there are some two kinds of reactions are there. Okay, one is the oxidation reaction and there is the reduction reaction. So which is the oxidation reaction, or where oxidation occur, where reduction occur? You know, in case of oxidation, you know, there is a loss of electrons. Okay, in case of oxidation there is a loss of electrons, but in case of reduction there is a gain of electrons. Okay, there is a gain of electrons. So if you think about the oxidation, then look here that in the left hand side electrode, here this is a loss of electrons. Okay, loss of electrons, so 2 electrons. So if there is loss of electrons, so that means here oxidation occur. In the left hand side here oxidation occur, because here each and every zinc atom, it comes to the solution by losing 2 electrons, so here oxidation occur. In the right hand side electrode, what happened? In the right hand side electrode, look there gaining of electrons occur. Okay, because copper 2 plus, after taking 2 electrons, it is converted to the neutral copper. So if the gaining of electrons occur, it is called the reduction. And you know that overall oxidation and reduction is called the redox reaction. So overall oxidation and reduction reaction is called the redox reaction. So cell means actually it is the combination of oxidation or reduction reaction. Okay, it is the combination of oxidation and reduction reaction, and also there is some kinds of fact that where oxidation occur, where reduction occur. That means there may be such kind of question arise in your mind, that why in the zinc electrode there oxidation occur and why in the copper electrode reduction occur. Why not the opposite? Because this comes from the electrochemical series. Okay, so what is the electrochemical series, or how we can determine that where oxidation occur, where reduction occur, I will discuss obviously but later. But there is some kinds of explanation also available, that of why in the zinc electrode there oxidation occur and why in the copper electrode reduction occur. Okay, I will explain later, but at this moment just try to understand that in the zinc electrode there oxidation occur. And another thing you have to keep in mind, where oxidation occur, in which electrode there oxidation occur, this will be anode. Okay, just keep in mind, where oxidation occur, this will call the anode. And where reduction occur, this will call the cathode. This you have to keep in mind, that which one is the anode and which one is the cathode, because this is very important fact for each and every types of cell you have to identify which one is the anode and which one is the cathode. So from that point of view you have to keep in mind properly which is the anode and which is the cathode. Okay, so now another thing, so here zinc is the anode. Okay, so if you consider here, it is the anode, it is the anode. Okay, it is the anode and it is the cathode. One is the anode and this is the cathode. Okay, and in the another thing, which is the negative and which is the positive electrode. So negative one is the left hand side, because here zinc, after losing 2 electrons, it comes to the solution as Zn2 plus, so obviously it will be negative. And another one, it will be the positive, because why it is positive, because negative electron comes to positive side. So that means that zinc is the negative electrode and copper is the positive electrode. Now there is another thing which you have to understand properly, because that what we discussed till now, there are two such kind of chambers are there. In these two chambers, there we connect the two electrodes. There are two electrodes are there, or two metal rods are dipped into the solution. Okay, then we connect the two metal rods through a wire. Okay, so this is the ultimate picture what we discussed till now, and we are getting the electricity. Okay, because why we are getting the electricity, because actually there is a flowing of the electrons through the wire. Now you have to understand properly. That is it possible to get the electrons continuously, or that means to get the electricity continuously from the cell? Is it possible? No, it is not possible. If you keep the cell in this moment, or up to that portion what we discussed, after some times the generation of the electricity will be stopped. The generation of the electricity that will be stopped after few hours. Why generation of the electricity will be stopped after some time? Because electrical neutrality is not maintained here. What is the electrical neutrality? Electrical neutrality means, just try to understand that here, that each and every Zn2 plus comes to the solution. Okay, each and every Zn2 plus comes to the solution. So after some time, the side of the electrodes will be covered by the Zn2 plus. If the side of the electrodes covered by the Zn2 plus, then what happens? It is not possible for the further conversion of zinc to Zn2 plus. That means if each and every zinc, the further conversion from zinc to Zn2 plus is not possible, then obviously their generation of the electrons will not be possible. If generation of the electrons is not possible, then obviously there is no chance of the flowing of the electrons. Ultimately will not get any kind of electricity from the cell. That means after few hours, or after some times, the reaction will be stopped. Hence, the generation of the electricity will be stopped. So, what is the solution for this? Okay, the solution is that, what is the solution? If it is the chamber, it is the any chamber for the like left hand side chamber, and in this chamber, if there is the if there is the zinc sulfate solution, and there is a metal rod which is dipped into the solution, then what we have to do, this is the metal rod, and in this metal rod, suppose what I told you, that in this metal rod, there it is the full of the Zn2 plus, which is covered by the covered surface of the electrodes by the Zn2 plus. And there is another chamber also, and in this chamber there is a same process. By the same process, there is a copper electrode is the covered by the SO4 2 minus ion, because each and every copper 2 plus goes to the electrode, and when each and every copper 2 plus goes to the electrode, then obviously SO4 2 minus remaining part covers to the surface of the electrode. So what we have to do, we have to connect the two chambers. We have to, how we can get relief from this problem? We have to connect the two chambers by the salt bridge. Okay, what is a salt bridge? Salt bridge, generally it looks like a U-tube. Okay, it looks like a U-tube, and where there is with the agar-agar solution, generally KCl is used here. Okay, KCl is used here. So KCl, what happened for KCl? KCl maintains the electrical neutrality. It helps to free this such that the surface will be free from the Zn2 plus. Here also surface will be free from the SO4 2 minus. So the role of the KCl is to maintain the electrical neutrality such that there will be smooth conversion of the zinc to Zn2 plus. Here smooth conversion of the here smooth conversion of the copper 2 plus to copper. So if we connect the two chambers by the salt bridge, then only it is possible to get the continuous flow of the electrons, and ultimately we will get the continuous electricity from the cell, otherwise not. Okay, so now there may be a question that what is the role of the KCl? The role of the KCl is to there isn't that the average velocity of the K plus and Cl minus will be same, so ionic mobility more or less it will be same. So that's why we are using the KCl in the salt bridge in the paste manner, okay, with the agar-agar gel. And the role of the salt bridge is to maintain the electrical neutrality for between the two chambers, and ultimately we will get the continuous flow up. Okay, now come to the point that what is the electrolytic cell. What I told you, electrolytic cell just opposite that of electrochemical cell. Okay, so electrolytic cell just opposite that of electrolytic cell, electrochemical cell. So if it is the electrolytic cell, then what we have to do, this is the chamber, and in this chamber suppose we are taking that any electrolyte, for example NaCl, we are taking the NaCl as the electrolyte in the as the electrolyte for the electrolytic cell. Okay, so now here we have to dip again the again dip the electrode in the solution, and for that purpose what we have to do, we have to choose the inert electrode. Okay, so you have to keep in mind, like the previous case also, here it is not required to participate the electrodes in the reaction, so electrodes will be inert in this process. Okay, so that's why here we will dip the inert electrodes. Okay, so and for example, you know, platinum is a very good inert electrode, so here we will dip the inert to inert electrodes. Okay, so suppose these are the two inert electrodes. Okay, we dipped into the solution. Okay, two inert electrodes are dipped into the solution. So now what happen if we dipped into the solution to inert electrodes, and we have to connect the two chambers to two electrodes through a battery, because it is the it is the electrolytic cell. So if it is the electrolytic cell, so obviously there you have to supply the energy from outside or the battery. Okay, so you have to supply the energy from outside, so that means you have to connect the battery. So if you connect the battery, there will be two sides, one will be negative and there will be positive side, isn't it? One will be negative electrode and there will be positive electrode, because electrolytic cell, there is a definition that electrical energy that will be converted to chemical energy. Electrical energy is converted to the chemical energy. So that means obviously there at first you have to supply the electricity or the electrical energy. So suppose we are connecting with the battery, negative and positive side, so that means this is the negative and this is the positive. Okay, so now in the solution, look here, there are two ions, one is the Na plus, another is the Cl minus. Okay, if there are two ions, Na plus and Cl minus, obviously Na plus has a tendency to it will be attracted by the negative electrode, and Cl minus will be attracted by the positive electrode. There is a common tendency of the cation and anion. Cation will go to the negative electrode and anion will go to the positive electrode. Then what happens? There will be two reaction. Suppose it is the left hand side electrode, it is the right hand side electrode. So for left hand side, what will be the reaction? So Na plus after taking one electrode, it is converted to the Na, simple case. And right hand side electrode, Cl minus, after losing one electrode, it is converted to the Cl, and Cl plus Cl, it is converted to the Cl2. So now what is the overall reaction? The overall reaction is that we are getting the overall reaction in this way, that Na plus Cl minus. Okay, so Na will be converted to the Na plus will be converted to the Na, and Cl minus will converted to the Cl2. Finally, this is the overall reaction. So now look here, what is the where oxidation occur and where reduction occur. So in the left hand side electrode, there are loss of electrons. isn't it? The loss of electrons. So if their loss of electrons occur, then it is expected, this is the example of the oxidation. Okay, no, sorry, in the left hand side electrode there is a gain of electrons. Okay, so in the left hand side this is the gain of electrons, Na plus plus E, this is the gain of electrons. So it is the example of the reduction where gain of electrons occur. So in the left hand side this is the reduction and it is the cathode. Okay, this is the cathode. But in the right hand side electrode there is a loss of electrons occur, Cl minus E to Cl2. Okay, Cl2 then Cl2. So loss of electrons occur. Loss of electrons means it is the oxidation, and oxidation means it is actually anode. I told you that where oxidation occur, this will be the anode. Okay, both are platinum electrode. Okay. So what happened here? First of all, we are supplying some electricity from the outside. Then we are using the platinum, which is used here as an inert electrode. Then there are some kinds of reaction we are getting. So that means, what is the meaning of that? The electrical energy is converted to the chemical energy, and that's why if electrical energy is converted to the chemical energy, that means it is the example of electrolytic cell. Okay. Now if you compare that it is the cathode, here cathode is the negative sign, just check the previous one. If you go to the previous one, there you will find out, okay, the example of the cathode. If you check the previous one, the example of the cathode, look there it will be the opposite sign. Okay, the example of the cathode, there it will be the opposite sign. Okay, just look there it will be understand, because we have to differentiate between electrochemical cell and the electrolytic cell. Okay, so just look here anode is the negative sign, here anode negative sign, and cathode is the positive sign. But in case of electrolytic cell, here cathode negative sign and anode is the positive sign. Okay. So if we differentiate between electrochemical and electrolytic cell, what will be the difference between electrochemical and electrolytic cell? So first one, if we write down electrochemical, and right hand side there electrolytic. Okay, so first of all, direction of the flow of the energy. Okay, direction of the flow of the energy means here chemical energy that is converted to the electrical energy. Chemical energy is converted to the electrical energy, and here right hand side there electrical energy that converted to the chemical energy. Okay, then second point may be here electrode takes part in the reaction. Okay, here takes part in the reaction, but here we use the inert electrode that will not take part in the reaction. That means platinum, here generally use here the platinum. So platinum here it generally not takes part in the reaction. So that's why here there is no scope of to come to the solution or like that. Okay, so there is another difference. Third difference here, it is the there is the generally the salt bridge is used in case of electrochemical cell, but in the right hand side there is a one chamber. There is no case of the two chambers in case of electrolytic cell. Just you see that there is no case of using the salt bridge also. Okay, so these are the differences between the electrochemical cell and the electrolytic cell. Okay, so now what I told you, that you in your mind there may be a question that why zinc is oxidized and copper is reduced. There is a term like EMF. Okay, so what is the EMF? For electromotive force. Actually this force is responsible for the flowing of the electrons or to conduct the reaction of this process. Okay, so this EMF, we will discuss about the EMF or the reduction potential of these things in the next class. But before that, you have to know that in case of electrochemical cell, you know there are some there are two half cells are there. Okay, so this each and every half cell, this is the one half cell and this is the another half cell. Okay, so each and every half cell there is some kind of potential value. Okay, either reduction potential value, oxidation potential value. Depending on this potential value, actually we get the ultimate flowing of the electrons or ultimate reaction process. Okay, so in the next class we'll discuss in details about the EMF, discuss about the reduction potential value, that how the reduction EMF and the Gibbs free energy, they are interrelated with each other, and the most important topic of this chapter, there is a Nernst equation, and obviously we will solve so a few numerical problems also there depending on the Nernst equation, because in electrochemistry also there are so many numerical problems are there in electrochemistry also. So we have to solve some sample numerical problems also in the electrochemistry chapter. Okay, so today we had discussed in details about the what is the cell, what is the definition of the cell, then what is the electrochemical cell, what is the electrolytic cell, then how we can establish that the flow of or the change of the energy from one form to another form for electrochemical cell, and for one form to another form for electrolytic cell also we discussed. And then we understand that how we can choose that which is the anode and which is the cathode. Okay, and how the sign of the sign of the electrodes, how it comes from the sign of the exactly different. Okay, so this may be the another point of the difference between the electrochemical cell and electrolytic cell, because in case of electrochemical cell their anode is negative, and in case of electrolytic cell their cathode is negative. But in case of electrochemical cell their cathode is positive, in case of electrolytic cell their anode is positive. Okay, so this may be the another difference. So we can differentiate also from the concept of the electrochemical cell or electrolytic cell. We discussed about the zinc copper cell. This is called the voltaic cell also. Okay, this is and the name is the galvanic cell or voltaic cell also. Okay, so then we discussed about the electrolytic cell, where NaCl we have taken the NaCl as the electrolyte, and we use the inert electrode. Okay, so that's all for today. So you have to read in details about these topics, because without this knowledge it is not possible to discuss the next class. Okay, so thanks for watching and take care. Goodbye.